All right, today we're talking about reflections. Our goals today are going to be able to perform reflections, perform something called glide reflections, and then identify lines of symmetry. Now, last class we talked about translations, and another word for translation was slide, right? We're sliding, we're going to move a figure, okay? Well, reflection, what's another word for reflecting? Mirror, I would agree there. Any others? Flip. Okay? I think those two, maybe there are others out there, those two are the ones that come to my mind. Okay? So a reflection, again, is another word for a flip. Okay? It's a transformation that uses a line like a mirror to reflect a figure. Okay, so we go down to example 1 here. It says graph triangle ABC with vertices that are given. So A is the point 1, 3. B is the point 5, 2. And C is the point 2, 1. Guys, and I will say this, I think it's helpful to have maybe 2 colors, and I'm going to use 2 colors up here. If you have maybe another pen or something you want to do, or you'd want to maybe use a colored pencil, I do have a colored pencil, just to kind of see, because sometimes there just gets to be a lot going on. Does anyone want a colored pencil in mind? They're in the drawer over there by Keaton. Nobody?
I will take one.
Okay. Okay, so we're going to reflect over the line x equals 3. Now, we talked about this last chapter. What does the line x equals 3 look like? Up and down or side to side?
Side to side. No, up and down.
Up and down. I'm going to go over to 3 on my x-axis. Okay, and this is going to be our line of reflection. Okay, that is the line we're going to reflect over. Okay, now here's how we're going to do this. As long as we're reflecting over a horizontal or a vertical line, we're going to do it this method. Okay, so here we go. I'm going to take point A. Now, point A is how many units away from the axis of symmetry?
2.
It's 2, so therefore it's 2 left. Well, now I need to make it 2 to the right. So this point right there would be A prime. And I can continue to do that with all of my other points. So B is 2 units away from our line of reflection or axis of symmetry. So I know it needs to be 2 to the left. So there's B prime. And C then is 1 unit away from our axis of symmetry. 1 unit to the left, so now it needs to be 1 unit to the right. This one kind of gets busy just because we're reflecting on top of each other, but I think we can see that the red triangle, the pre-image, is the same size and shape as the blue triangle, the image. Questions there? Okay, we have to draw triangle ABC in again. So A is 1, 3. B is 5, 2. And C is 2, 1. Okay, now y equals 1. What's that line going to look like?
Horizontal.
Horizontal at 1, right? So I go 1 on the y-axis. And it's going to be horizontal there. Same idea. So if I look at A is 2 units above the line of symmetry, axis of symmetry, axis of reflection, whatever you want to call it, is 2 units above, so now we're going to be 2 units below. There's A prime. B is 1 unit above, so now it's going to be 1 unit below. In C, where does C lie? It's on the line of reflection, isn't it? So it's going to stay there. So C and C prime are actually the same point. Now again, when you're all finished, we should stop and ask ourselves, if I folded my paper on the line of reflection, would the pre-image be mapped or be where the image is? And I think this one, that turns to be true. Okay. Now, reflecting over the line y equals x. What does the line y equals x look like?
Vertical.
Vertical? Not vertical. Now, is the line y equals x, is that in slope-intercept form?
Uh-huh.
What's my slope, Morgan?
Oh, what?
Morgan? Thank you. 1. What's my y-intercept? Here, Jevin? 0. So the line y equals x is in slope-intercept form. The slope is 1, so we usually don't write it, and the y-intercept is 0, so we usually don't write it. So 1x plus 0, that means I'm going to start at my y-intercept, which is 0, and we're going to go up 1 over 1. So this is the line y equals x. That's the line y equals x. Now, let's look at this point right here. Let's look at the point, call that point A. That is the point 1, 3. Now, if I were to reflect the point 1, 3, point A, over the axis of symmetry, over the line y equals x, where do you guys think it would be? Shane?
1, -2.
1, -2. Let's check here. 1, negative, down here?
Yeah.
Would you guys agree or disagree with that?
I disagree.
Now, Shane, I want you to think about this. If I folded point A, if I folded the paper on the axis of symmetry, would A be down here?
Sorry, -1.
If I folded my paper, would it be over there? Now, if I folded this guy across this paper, wouldn't it be somewhere in this ballpark?
Okay, I got you.
Would you guys see that? Courtney, what do you think?
3, 1.
3, 1. Let's try that. What do you guys think of Courtney's there?
Yes.
Now, again, stop and ask yourself. You can literally almost fold your paper over. Would A be mapped? Mapped. Is it just a fancy word to be, hey, would it be put on there, or where would it end up? A would be mapped to A prime. Would you guys agree there? Now, what happened, I guess Courtney said A prime was 3, 1. What happened to our coordinates there?
Opposite. Like the x is y and y is x.
The x and y are switched. Okay? X and y are switched. So, here's just a way to write it. We can say, hey, x, I don't want to do that. Let's do A. Let's do A, B, a point with the x coordinate of A and the y coordinate of B, after we reflect over the line y equals x, is going to be B comma A. We're just going to switch our x and y coordinates. That's pretty sweet, huh?
Yes.
So, if we're reflecting over a line that's vertical or horizontal, we're going to think of it doing it that way. If we reflect over the line y equals x, we're going to do it this way. Now, the line y equals negative x. Caitlin, what's the slope of the line y equals negative x? Great, it's -1. Alex, what's the y-intercept there of y equals negative x? 0. So my y-intercept is 0, and then I'm going to have a negative slope, or slope of -1. So the line y equals negative x looks like this. That is a really good line, isn't it, Shane? That is very good. Okay, so I'm going to go back to point A here, and let's think about that. So if A was 1, 3, don't shout it out. I want you to think about it. Where do you think A prime is going to be? I reflect A over the line y equals negative x. Where do you think A prime will be? Talk to the person next to you.
-3, -1.
-3, -1. Now if I plot that, -3, -1, Jake's saying that would be A prime. Now again, would A be mapped to A prime if I folded it on that line?
Yeah.
I think it would. So what do we notice about the coordinates? Here, Pierce, what do we notice?
They're flipped and they're opposite.
Okay, good. We're going to switch our x and our y, meaning we're going to change the location of them, and then we're going to flip the signs. So switch where they are and flip the sign. So if I did it in this notation, this would be opposite of B, opposite of A. We're going to flip their location, switch the sign. Alrighty, here we go. It says we've got triangle DEF with those points. So let's go ahead and plot those, please. -2, 1, 2, 3, 4, 6. And actually, guys, why don't you do this on both graphs right now and just get it over with. Okay, so there's our pre-image. And on this first one, we're going to reflect over the line y equals x. So I'm going to go ahead and make that. The line y equals x looks like this. Okay, and I truly believe the best way to do this, guys, is to write out the coordinates. So I'm going to write D prime, I'm going to write E prime, and F prime. So, again, remind me, if I reflect over the line y equals x, Keishan, what do I do with my coordinates? If I'm going to reflect over the line y equals x, what do I do with my coordinates?
And change the signs.
Line y equals x. Let's go back up. Let's look up above. Here we just switch their locations. Okay? Switch their locations. Don't make them negative. We're just going to switch them. So D was the point -2, 6. Now it's going to become the point 6, -2. E was the point 3, 6. Now it's going to become 6, 3. And F is going to become, or F prime rather, which should be 3, 1. And now we can go ahead and plot those points. So 6, negative 2. 6, 3. Now when we're finished, I always ask ourselves, if I folded on that line, would I end up in the, if I fold the triangle DEF down over the line y equals x, would I be at D prime, E prime, F prime? I think I would. Secondly, have these shapes changed size or shape? No. What's that word called again? If it doesn't change size or shape. Congruent, I would agree with that. That's not the word I was thinking of, or the word we learned last class.
Dilation.
No, dilation is when they get bigger. Let's get out those notes. Let's figure out what's that word. Actually, there's two correct answers here. One hint is it's a type of power tool. Rigid motion. Ever heard of rigid power tools? Rigid motion or isometry. So if it preserves a size and angle measure, then it's called an isometry. Okay? So now we're going to reflect over the line y equals negative x. So I'm going to make that line here. Again, I'm going to write out my coordinates. So D prime, E prime, F prime. So again, now we're reflecting over the line y equals negative x. What do I do with my coordinates? Colleen, do you remember?
Yeah, you flip their location and then you switch the sign.
Great. Flip their location, switch the sign. So D prime is going to be negative 6, positive 2. E prime is going to be negative 6, negative 3. And F prime is going to be negative 3, negative 1. Okay, let's plot these. Negative 6, 2. Negative 6, negative 3. Negative 3, negative 1. Questions here at all? Okay, top of the next page. Talking about a glide reflection. Glide rhymes with slide, right? So all we're going to do is we're going to slide it or have a translation. So it's a transformation involving a translation followed by a reflection. So we're going to slide it first, then reflect it. So here it says, graph triangle ABC with the vertices and its image after the glide reflection. So let's graph those, ABC here. Okay, there we go. Now, I made a mistake here. This parenthesis should be going the other way. Obviously, I wasn't being very careful. So this translation, can anyone in words describe to me how we're going to translate it? Which direction and how much? Ellie, can you do that?
Maybe
12. Which direction? Left, right? Because we're subtracting. So we're just going to go 12 left. What are we doing to our y? Yeah, we're going to keep it the same. It's not going to go anywhere up or down. All we're doing is going to go straight 12 left. Okay, so we're going to take 12 left here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be A prime. B then would be right there. Now, has the size or shape changed? No, and it shouldn't. Okay, so make sure that's the case before we reflect it. Now we're going to reflect it in the x-axis. That's just a way to say, hey, we're going to reflect it over the x-axis. Okay, so if I do another color here, A is 2 units away from our axis of symmetry, which is our x-axis. So A prime, actually I should say A double prime, should be 2 units below. B is 3 units above my axis of symmetry, so B prime, I should say, B prime is 3 units above, so B double prime should be 3 units below. And then C prime is 1 unit above, so it'll be 1 unit below. So as you can see, we went from ABC and slid it over to A prime, B prime, C prime, and then we reflected it over the x-axis, which is A double prime, B double prime, C double prime. Questions there? Okay, last idea here is this idea of recognizing lines of symmetry. So a line of symmetry is a line of reflection that maps onto itself. Okay, again, maps would just be, hey, if you folded something or you reflected it, it would actually be on the same figure. So, how many lines of symmetry does each figure have? Let's actually draw them in there. So, can you describe one of them for me? Hamburger, right? Cutting it hamburger style. That'd be one. If you folded the figure on that line, it would map to itself. Ellie? Yeah, kind of hot dog. Going this direction. We fold it along that line. It would map onto itself. What about this line?
Yeah, that would work.
Would that work?
No.
So if I folded this figure on this line, wouldn't this point end up being way up here? Yeah, so that doesn't work. I think we've just got 2 of them there. We just have 2 lines of symmetry. Now, this next one, Jevin, can you describe one? One axis of symmetry, one line of symmetry? Sure. What do you mean by that? This direction? So we cut it right like that. Now, didn't we go from like vertice to vertice? Yes? So can't we go from vertice to vertice that way? And then we've got 2 more vertices to go through. That guy right there. So there's got to be 3 of them here, huh?
No,
There's
record match.
What do you mean, Shane?
You can cut it in half again.
What do you mean?
Not through the vertices, but like in between the two.
Oh, so instead of drawing them on the vertice, let's draw it like right in the middle of a side.
Yeah.
So there's one.
So would there be infinite?
Ooh. Oops, shouldn't have done that. So what'd you say, Hannes? Isn't there infinite?
Yeah. Because there's infinite points on the line. So you can keep on cutting it.
Could I cut it right here?
Yeah.
Is the blue line in a line of symmetry?
Wait, no,
No, the blue line's not. So how many do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pierce, how many do I have?
6.
I've got 6 of them, right? Don't count them twice. I've got 1 here, 2, 3, 4, 5, 6. This one I've already counted up there. So I have 6 lines of symmetry there. And lastly, real quick, I've got, I believe, 1 line of symmetry there.